We're going to look at generating random numbers today. There's a couple of different ways we can do it, and it depends on the type of random number that we want to generate. One of the easiest is to use Java's random class. So we can say random and create a new instance of it. So we can say random generator equals new random. Okay. One thing I will say about this, and in fact all of the random things we're going to look at today, is that they are not what are called secure random numbers. So they're pseudo random numbers. They're not real, purely random. For most purposes, they'll be random. But if you, for example, were wanting to use it for cryptography, or for example, you needed to generate a random number for a game of chance that had, financial implications, it's not a pure random number. So computers can't really, if we didn't have random, you might say, well, how do you generate a random number? Humans can pluck a random number out of the air. A computer, there are methods to do the equivalent of that, looking at sort of things that are external to the computer. For example, variations in spin speed of hard drives or mouse, the fine movements of a mouse on a computer. But to all intents and purposes, the techniques we're going to use today are using a predefined random number generation that you could, if you knew the point at which the random number was being generated and the system that was doing the generation could anticipate what those random numbers would be. So just bear that in mind. Don't use it for anything to do with finance or cryptography, anything for that kind of thing. But for most purposes, it will be okay. So here's a random number generator. We can ask our random number generator essentially for the next integer, or the next Boolean value, or the next double. Now, depending on which method we're going to call, we can specify some constraints. So if we just use nextInt, okay, we'll get a random integer. So let's just try that and store it in a variable. Int random int equals, and we'll print that out. And we'll run it. And we'll get a random number. But as you can see, it uses the full integer range. So in this particular example, we've got a negative number. Let's run it again. This time we've got a positive number. Okay. Now, fortunately, we can specify a bounds. Okay. So this is an upper limit. And if we do that, it will impose a lower limit of 0. Okay. So if I put, for example, 5, it will now generate me a random number between 0 and 5. There we go, a 1. And just as an example, we could put this code in a loop. We could run it, let's say 10 times, and we'll get 10 random numbers. There we go. So you can see we've got we've got 3 noughts, and actually a couple of three threes, just 1 1, 1 2, 1 4. Oh no, 2 2s. But you can see it's bound within that range. So that's an easy way of getting a random number. One question that's often asked, well, what if I wanted a number between, let's say, 5 and 10? Well, the easy answer there is just to add the difference between your bottom number and your top number on. So if we wanted to start at 5, we could just add 5 to the result, and the upper number will be, in this case, 1 less than 10. Okay, so you notice here the upper bound is 5. We go up to, but not including that upper bound. So there are 5 possible numbers, 0, 1, 2, 3, and 4 that could come out. If I want a number between 5 and 10 and including 10, I'd set the bound to 6. Okay, so that will get us a number here between 0 and 5, but when we add 5 to that, it will get us a number between 4 and 10 inclusive. So if we run it, there's a good chance we'll get a 10. There we go, there's a 10, and we've got a 5. So that gets us a random number within some parameters. You could do the same if you wanted negative numbers. We haven't got quite the same amount of control so on our other types. So if we look at our random generator again, next double. Okay, now if we run this a few times, we can see what sort of values we get here. Random double, and we'll print that out. Okay, and you'll see that these are all constrained between 0 inclusive and 1 not inclusive. Obviously, there's a very large range of precision, so we'd probably be unlikely to get a 0, but it's possible. We wouldn't get a 1, but we could get 0.9 recurring essentially, up until the most precision number we can get stored below 1. So we can do the same there. We can also use the math class, so you can do math.random. That just gives us a random double. So in fact, let's just do .random. We don't need a random generator anymore. Okay, and we can print out our random double, and we can run that. We can't, we don't, because we haven't got the bounds. If we want a random number, and if we wanted a random number that was a double between, let's say, 5 and 10, that things get a little bit more complicated. Now we can obviously scale this number. Okay, so if we took 1 as the highest number we'd want, if we wanted it between, say, 0 and up to and not including 10, we could just multiply a random number by 10. Okay, if we wanted it between, let's say, 5 and up to and not including 10, just to keep the maths easy, we could multiply it by 5. That would give us a range of 5 digits from 0 up to and not including 5, so up to 4.9. So we could do that, and then we could add on, if we wanted it from 5 to 10, we could add 5 to that. So if we run that, you'll now see that we've got values from 5 up to essentially 9.9999. Okay, so there are ways of getting values within a particular range, be it an integer range or a range of doubles, by scaling the value, which is between 0 and 1, up until whatever range we want it in. So we basically work out how big the range it is and multiply it by that. And then if the bottom of that range is not 0, we just add on whatever number we need to get to the bottom of, to get the number we want to start at. So in this case, we're starting at 5. Okay. As I say, you can use it for the random class. We go back to the random class. So math just gives us doubles if we use math.random, but the random class, we have to create an instance of random, so it's an extra line of code, I guess. We can also get, for example, a Boolean, okay, or float. So we can get other data types there as well. Boolean can be useful if we want to say if and only do things half the time at random. So, if let's say random generator dot next Boolean, print out heads, else, tails. In fact, I want to print that, so we can run that and see that happen. Heads, tails, heads again, tails again. Very even distribution. Got 2 tails in a row there. So that's potentially quite useful. The other thing just to mention is sometimes we might want to have the same set of random numbers generated. Okay, let me give you an example. Let's say we're developing a game and we want to have characters, our non-player characters, spawn at random. So we want certain things to happen at random, okay? And let's say we're recording the actions that the user is putting through the gamepad or the keyboard to play the game, so that we can replay or regenerate that game rather than recording sort of what the player does. We just record their actions, and we want the behavior to be the same if they were to do a replay, okay? But we're not actually storing a representation. Let's say it's a 3D game of a video. We just want to know what they pressed on the keyboard or the gamepad. But for that to work, you'd need the randomness of your non-player characters to be the same. Okay, and what we can do is we can generate a what's called a seed. So we can supply a number in here. Okay, so we'll just use any number, any integer. Okay, and I'm gonna just create a loop that generates 10 random numbers. So I'm gonna say for I, oops, but I is less than 10, I'm gonna print out the next integer. Okay, and I'm just gonna set the bounds at 10 just to keep life. In fact, yeah, I keep life fairly straightforward, and we'll run it. Okay, and if we look at this, the numbers are 8, 5, 5, 1, 9, 0. They're the first few. Let's run it again. 8, 5, 5, 1, 9, 0. So we get the same set of results. So what we can do is we can generate a random number, use that random number, store that random number, and then if we want to get the same sequence of random numbers again, we can simply use the same seed and we'll get the same set of results. So yeah, I think that's about it for random numbers.